Hello everyone, my name is Roy Jafari and I would like to welcome you to another video. In this video, we're going to talk about this question: what is big data? And it's going to be a short video, and in this video, we're going to have an answer to this question that is going to be useful for our journey in machine learning and data analytics. So let's get started. The first thing I want to say is that I have recently created another video regarding what is data. I'm going to put the link for that video in the description and also in the link above here. All right, so take a look at that. Now let's go back to the answer to the question, what is big data, right? So the question, what is big data, is normally answered with one of these, sort of like definition. Is more than a specific number of rows in a database or in a source of data, more than a specific size of data, like maybe like 64 petabyte of data, or more than 20 sources, or like whatever number of sources of data, then we start calling them big data. And that is actually very incorrect. That's the worst way to define big data. The problem with this type of sort of like defining big data is that this goalpost will keep changing as we start using more and more data, and also our technology become more advanced. We have to change these goalposts, right? So in this video, I'm going to offer a definition that is going to be long-standing. It's going to be useful for our understanding than our journey for big data, for data analytics and machine learning, right? So before we do that, before we get to the definition, let's talk about the direction of growth, right? So the whole thing about big data is about something about size. There are three size-like or size-related, directions of growth about data that can change this size of the data. And these things are actually, these three, directions of growth are very famous, and they're known as 3 V's of big data. And they are volume, variety, and velocity. So volume is very simple. Like if, we have a data, right? We have data, and, the data objects could be anything, right? Let's say the data objects are Facebook's posts, right? The volume of the data is going to be the number of Facebook posts, right? If the data objects are users, right, social media users, then the volume of that data is going to be the number of social media users. Roughly, you could think of volume of the data as the number of rows. Like I said, roughly, it's not an accurate definition, but the accurate definition of volume would be the number of data objects that you have in your data. So that would be volume. Then we have variety. Variety is the multiple sources of data that you have, right? So in the example of Facebook post, right? So if we are trying to understand our Facebook users, so Facebook users are one source of data, and then each of these users, also have some behavior for their posts. So that's another source of data. They also have some behavior in liking the other's post, another source of data. They also have another behavior in commenting, another source of data. Not only that, also Facebook may have some other data, such as the other apps that they use, the behavior of the same user on Instagram, on WhatsApp, and also some other external data sources, right? As you can see, as the sources of data that have new information increases, then also the variety increases, right? So that's volume, variety, and the third one is velocity. Velocity is the rate with which new data objects come to our databases, whatever we record them, right? So, for instance, the velocity of Facebook's users are less than the velocity of the database of Facebook's posts, right? So the Facebook posts keep happening, you've got so many users, and they post 1 or 2 a day, and then the velocity is higher than the velocity of just the users, right? So the velocity is the speed at which new data objects comes in, right? So the point here is for us to understand directions of growth. So if we increase the volume, variety, and velocity, we may change the size of the data, right? So that's basically the 3 directions of growth. So pay attention. We haven't still answered the question, what is big data? And I'm going to use these 3 V's to answer that question. And here's the answer to that question. What is big data? The definition has 3 parts, right? The first part is big data is not some characteristics of some data, right? So I'm actually sharing with you that it's not good for us to define big data as some characteristic of the data. However, it is better for us to define big data as situations that happens to individuals or organization, right? So that's the first thing. The second thing is it's about a struggle, right? They go through for analyzing, preparing, optimizing, whatever they want to do with the data because of the size of the data, right? So, and that's, because of the size of the data and also their knowledge, their skills, technology, and whatever it is that they use to get those values from the data, right? So in this definition, whatever the technology you have, even if you change them and you start having bigger data, your volume, variety, and velocity of the data changes, you may still have to face big data, right? So that's the definition of the big data that I'm putting out there. And another topic we want to discuss here is some strategies to solve big data, right? So there are 3 strategies we can think about when we face big data. What are the things that we do? The first thing is, just throw some money at it, right? If we have a code that runs, some time, maybe we can buy better computation, right? If we buy better computation, bigger computing power, it may make it run it faster, right? So that's just throwing some money at your problem. Scaling up, you could learn some new tools, some new techniques, some new methods, some new approaches, and you'll optimize your codes. Or you could hire as an organization some other techniques and tools that could help you improve your solutions and be better at dealing with larger size of data, higher volume, higher velocity, and higher variety. The last one is compromising, right? At some point, you are going to have to accept that this is going to be the performance I'm going to give. It may sound like compromising is sort of kind of accepting defeat. However, this is actually present in any solution that you have. For instance, the best data solution that we all get to use every day, Google search, it takes 0.2 seconds, right? Every time you search for it to give you a result, right? This 0.2 second is something that the designer of the solution, designer of the Google search has actually decided, right? There are so many computers behind the scene of that with the search box that makes sure that you get this performance. If they wanted to throw more money at this, they may have been able to bring it down to 0.1 second. And that's the compromise they have found based on how much money they want to throw at it, right? So these are the 3 strategies we deal with big data. Lastly, I want to sort of also give you another concept, and that is big data situation, right? So big data situation is the challenge that organization or individual have to accept to go through. And by changing the culture, structure, methods, mindset, and working habits that they have, they would have to be able to face the big data situation. Pay attention. It might sound like the big data situation is only a technical issue. However, big data situation can also be cultural. Also, it has to be do infrastructure and other aspects of an organization. All right, that's the end of this video. I will see you in the next